Peter, we got a question on the chat. Cool, yeah, you're welcome. All right, so let's go to the annotated notes. All right, so if you remember, we last left off, we finished up 1.1. We also finished up 1.2. So we're gonna get started with 1.3. So 1.3 is the different way that we could do a random selection. All right. So right now you should be seeing the lecture note for chapter 1.3 and it just says random sample. All right, so let's get started. So the first random sample we're gonna go over is something called a simple random sampling, or SRS. So in lecture notes or in a quiz or in a test, if you ever see SRS, you should know what that symbolizes or what that means. SRS stands for a simple random sampling or a simple random sample. So once you see SRS, it is a simple random sample. So what a simple random sample is saying that everybody in the population should have an equal chance of getting chosen. So let's say for today, well, let's do a very basic. So the way that you get a simple random sample, everybody should have one, should have one in n many chances of getting chosen. Because if you remember, capital N correspond to your population size, in case you forgot that or don't remember that. So if you look at it, you have to, everybody has to have one in n chance of getting chosen. So let's take for today. So in today's lecture, there's 36 students. So we have 36 students. So since there's 36 students, that means the chances that I could randomly select a student is just 1 out of 36. So that will be a simple random sample. So simple random sample just means everybody in that population should have an equal opportunity of getting chosen or equal chance of getting chosen. All right. Everybody good for simple random sample? All right, so let's go into this next problem. So for this sample, it says, suppose a study group consists of 5 students: Bob, Patricia, Mike, Jan, and Tim. 2 of the students must go to the board to demonstrate a homework problem. List all possible samples of size 2 without replacement. So first thing we want to go is without replacement. So without replacement, what without replacement represent is saying that once we select an object or we select a person, we can't select that object or that person again. So whenever we use the word without replacement, it is saying once we select an object, we can't select that person or that object again, which kind of makes sense because if you kind of think about it, it's saying we're choosing 2 people to present a problem on a board. So it's kind of impossible for 2 people to be the same person presenting that problem. So it had to be 2 different persons. So what we want to do, we want to list all of the different samples. So all right, just to make this a little bit easier for Bob, Bob is going to be B, Patricia is going to be P, Mike is going to be M, Jan is going to be J, Tim is going to be T. All right, so one pairing that we could have, and let me do this in a different color, we could have Bob and Patricia could go on to the board and present a problem. We could also have Bob and Mike could go up to the board and present a problem. Or we could have Bob and Jen go up to the board and present a problem. And lastly, we could have Bob and Tim present a problem on the board. So those are right now we have 4 different outcomes. What's the other outcome that we could have? And you can just put it on the chat. Cool. PM. So we're going Patricia and Mike. And then after Patricia and Mike, we could say Patricia and Jan. Then we could say Patricia and Tim. All right. So yeah, so let's do the other one. So we could say Mike and Jan. We could say Mike and Tim. We could say Jan and Tim. And that's it. How about MT? Well, MT is right here. All right, so those are all of the different pairings. So pretty much for this, like each one of these pairings has an equal chance of getting chosen. All right, everybody good in regard to that? All right, no objection. Okay, so up next we're gonna go over something called a representative sample. So when we say a representative sample, we're talking about our sample should represent our entire population. So say if we're choosing, like, we want to know about people and what type of cell phone do they use, a representative sample should represent all different type of cell phone. It shouldn't just be that all of our sample is all, say, iPhone. It has to be a representative that all different cell phone or all different iOS devices get chosen. So we can't just have one particular thing. So for this example, this is my population. And this is my sample. So if you look at my sample, that's a sample size of 4. This is a population of 12. So if I look at my sample, does the sample represent the population? Like, does it seem that all the ducks are getting equally represented? Yeah. Well, which duck are not getting represented? Okay, if you look at it, we have the blue are getting represented by this duck. We have the red are actually getting represented by these 2 ducks. And we have the yellow duck getting represented by that duck. Cool, yeah. So if you actually look at the red ducks, why do you think the red ducks have more ducks in the sample? Yeah, because you have a bigger population of red ducks. So naturally, like if you're getting a sample, that's going to reflect on the sample because not all of these ducks are equally distributed. Because if you look at the blue ducks, there's only 3 of them. If you look at the red duck, there's 6 of them. If you look at the yellow duck, there's only 3 of them. So that's why when we get a sample, you kind of want there to be more red ducks because the population consists of more red ducks. So you kind of want to just take that. So that's a representative sample. All of the population getting represented and kind of each population getting equal representation. Kind of think about like with the electoral system, like each state get represented based on how much their population is. So if one population will in one state has a bigger population, they get more electoral votes because they have a bigger population. So same thing with the representative sample. If your population consists of one group and that group have more representation, for the sample, it should also have more representation. All right, so that's a representative sample. Everybody good for a representative sample? All right, perfect. All right. So let's go to 1.4. So in 1.4, we're going to learn different method to randomly select your population from. So this is going to be other than a simple random sample. So other than a simple random sample, there's going to be several other sampling, and that was 1.4 you're going to cover. So for 1.4, we're going to cover something called a stratified sampling or stratify sample. A stratified sample is when you divide your population based off of different groups. Once you divide the population based off of their different group, or they also call this strata, what you're gonna do, you're gonna randomly select from each strata or each group. So instead of me randomly selected from the entire population, we get the entire population, we break them up into different groups, and then we randomly select from those different groups. So here is my population. So if you look at this population, what different color do we have for our population? So what type of colored ducks do we have? All right, cool. So yeah, so we have the blue ducks over here. You have the red. Oh, that's it. And I guess we're saying pink or purple. We'll go with purple for the. So we have the blue ducks. We have the red ducks. And we have purple ducks. So what we're gonna do, we're gonna split them up based off of their color. So if you look at the blue ducks, how many blue ducks do we have? Yeah. So we have 6. So if you look at that, that's why we have 6 blue ducks right here. What about my purple ducks? How many purple ducks do we have? Cool, perfect. So we have 2 purple ducks. Lastly, how many red ducks do we have? 6. Sweet. All right. So if you look at it, I already split them up based off of the color. So we'll say the blue ducks, red ducks, and purple ducks. All right. So if you look at it, from this group, are all of the group have an equal weight? Like, are all group equally represented? Like, which 2 group should have more representation? Yeah. So the blue and the red should have more representation because they have a bigger group. Versus if you look at the purple group doesn't have that big of a representation. So when I randomly select from them, I'm not gonna randomly select that many things. So what we're gonna do for this one, we're gonna take a random sample of 3. We're gonna take a random sample of 3. And this one, we're gonna take a random sample of 1. Because if you look at it, that shit kind of makes sense. Because if you look at the purple compared to the blue and the red, the blue has 3 times as many ducks as compared to the purple. So the 3-to-1 ratio. So now what we could do, we could take a random selection. So we randomly select 3. We randomly select 3 red ducks. We randomly select 3 blue ducks, and you randomly select 1 purple duck. And that'll be it for that. So that's how a stratified sampling works. You first look at the group and you split them up based off of the group. Once you split them up based off of the group, you randomly select from each individual group. And you kind of want to make sure that depending on how big or how small that group is, it kind of going to dictate what type of sample you take from that population. Because I wouldn't want to take a bigger population of the purple compared to the red and compared to the blue, because if you look at it, the blue and the red have a bigger population compared to the purple. All right, everybody good for that example? All right, so say if we were in class, how can I split up how can I split up the class in a stratified sampling? So what's one way I could split you up into group and then randomly select from each group? Cool. All right, so one way we could do boys versus girl. Cool. All right, good. So that's one group. Quick question. Are you able to see where it says boys and girl in a box? All right, let me do a stop share and just reshare real quickly. All right, so there you go. Sorry about that. It happened from time to time. Cool. All right, so we do it based off of boys and girls. We also say age, so we could do like 18, I don't know, 20. We could do one group. Then we could do 21 to 25. Then we could do 26 to 30. And then we could do 31 and plus. Cool. So that's the other way you could split them up based off a particular group. So then what you have to do, once you break them up into that particular group, what you have to do, you have to randomly select from each group. So hypothetically, let's just say, here, let's do this. So I'm gonna do a poll. So if you identify as a boy, you select A. If you identify as a girl, I want you to randomly, well, not, I want you to select B. So I'm gonna launch a poll right now. So you have to either choose A or B. So A if you're a boy, B if you are a girl. Very sweet. All right, so for boys, we have 8 boys. For girls, we have 22. Sweet. So we'll say end poll. Here, we'll share the result. All right, so if you look at the poll, we got 8 boys and we got 22 girls. All right. So in this one, should I randomly select the same amount of boys as girl? Well, no, because if you look at it, there's way more many girls compared to boy. Because if you kind of look at it, it's kind of almost like a 3-to-1 ratio. Because if you look at it, there's 8 boys and there's 22 girls. So there's significantly more girl compared to boy. So if I do take a sample, say if I take a sample of 2 boys, you might want to take a sample of like 5 or 6 girl. Because the girl group had a bigger population compared to the boy. All right, and that's stratified sampling. Any question for stratified sampling? All right, so let's move on down. All right. So for the N, I'm not going to ask you to randomly for you to choose the N, but usually for N, you kind of just want to see how big of a sample size you want. And you have to just choose like from that. But for the N, don't really worry about how we choose that. You just kind of worry about like what go into getting a stratified sampling. All right, so let's do a systematic sample. So here you have my data set. So I number off all of my ducks. So we have duck number 1, duck number 2, duck number 3. So you put them in order. And what you want to do when you do a systematic sample, what you want to do, you want to pick every N person, or in this case, every K duck. So if you look at the ducks, which duck am I selecting? Every what duck? Yeah, good. So we're selecting. So we are selecting. So in this example, how many ducks did I select? Yeah, good. We selected 4. Because if you look at this one, I selected this duck with a Viking hat, this regular duck, this horse of a duck, and I guess seeing a duck that has glasses. All right. So that's how systematic sampling works. And if you want to decide how do you figure out like what the K term is, the way that you find it out is right here in the notes. If you look at it, it says capital N divided by N. So depending on how big your sample size is, it will tell you if you want to get like the every third one, every fourth one, so on and so forth. So if you look at this one, you could do 14 because that's how many total ducks we have. You could divide it by n. So say for our sample size, we want it to be 4. And we could do 14 divided by 4. So you get 3.5. So technically in this one, I should have selected the 4th duck. So I should have selected this duck, and well, still this duck. But technically that's how you go about choosing like which K of a term or which K of a duck that you should select. You do how big is your population and you divide it by how big of a sample size we want. So in this case, since our population theoretically is 14, you divide it by 4 because that's how big of a sample size we want. But don't really get hung up on that. You kind of know what a systematic sample is. A systematic sample is just when you start selecting every K person or every K object. All right, any question in regard to that first example? All right, so if we were in class, like how can I do a systematic sampling in class? So how can I do systematic sampling? Good. So yeah, so we could do it by seats. So we could go by seats and we could do every 4. Yeah. So we could do by seats every 4th student, or also if I have the row sheet, I could just use the row sheet and just go like I could just randomly select every 4th student or every 5th student or however big my sample size I want. So yeah. All right, and that's systematic sample. Any question in regard to systematic sample? All right, thank you. So no. All right, next one, we're gonna do a cluster sample. So for this one, cluster sample and stratify sampling, usually students get confused with this. So you do kind of want to take notes on what makes cluster sampling or a cluster sample different from a stratified sample. So for a cluster sample, what you want to do, you want to split up your data set into group. But in this group, you're not splitting them up based off of what do they have in common. You're just splitting them up by a natural like um, group. So kind of like one of the way that you could do a cluster sample, say if we wanted to do a sample about everybody that live in California. But the thing is, you can't really go about and get everybody in California. So what you kind of want to go ahead and do. All right, so that's California. So you could break up California into clusters. So you break them up into cluster, and then what you want to do, you randomly select a cluster. So pick a number from 1 to 12. And you type it into the chat, or if you want, you just yell it out. Cool, 2 people said the same number. So we got 8, we got 5, and you got 1. Cool. And we'll do 7 and 9. All right, good. All right. So what a cluster sampling is, you pretty much divide them into natural group. And once you divide them into natural group, you randomly select one of those cluster, or you could randomly select multiple of those cluster. Once you get the random cluster, what you want to do, instead of randomly selecting from that cluster, everybody inside of that cluster automatically get chosen. So the difference between a stratified sampling and a cluster, in a stratified sampling, once you divide it into group, you randomly select from that group. But for a cluster sample, once you randomly have these cluster, once you randomly select a cluster, everybody inside of the cluster automatically get chosen. So everybody in one, here, let me use a different color. Everybody in 1, 5, 7, 8, 9, everybody in that cluster automatically get chosen. So we don't have to randomly select them. Everybody in that cluster get chosen. Cool. All right, so here goes the second example. So here are my ducks. So for these ducks, if you look at it, they're holding a sign. So the sign represents which cluster they're in. So this one is in cluster 1, cluster 2, cluster 3, cluster 6, cluster 5, cluster 4. So what we want to do, we just want to randomly select a cluster. So if you look at this one, the 2 clusters that I randomly chose are 2 and 5. So since I randomly selected cluster 2 and 5, everybody in both of those clusters automatically get chosen. In this case, it's the ducks. So I randomly select, well, not randomly, I select everybody in cluster 2, everybody in cluster 5. And we're hoping that this sample is a representative sample. But that's it for that one. Any question in regards to this cluster sample? All right. So if I wanted to do a cluster sample in class, so you kind of want them, like you want each cluster to have a same sampling, because you don't want like because you don't want one cluster to have a bigger sampling than the other. So typically, like all of these should all be equally represented. So if one cluster have, say, 100 people, you want all the other clusters to have 100 people. And you're hoping that each cluster is representative of the entire population. And for this sampling, it's not as accurate as, say, as a simple random sample, but you kind of have to go, like, a simple random sample is a very hard sampling to do, because that one usually take up more money. A cluster sampling is usually cheaper to do because you just divide them based off of their groups. And then once you divide them based off of their group that they are in, you just randomly select everything. So it's not as accurate as a simple random sample, but it should give you a pretty accurate result. Any other question in regard to cluster sampling? Perfecto. All right. So say if we were in class, how can we do a cluster sample in class? Oh yeah. So you can just do by rows. So we could just say, this is row number 1. This is row number 2. Row number 3. So we can just divide the rows, and then we can just say, okay, I'm gonna randomly select this row, and we're gonna randomly select row number 3. And then you randomly select, well, sorry, you don't randomly select, but you select everybody in row 1 and row 3, and that will be your sample. Yeah. So just remember, for a cluster sample, once you have your cluster, once you select those cluster, everybody in that cluster or all the objects in that cluster are automatically chosen. In a stratified sampling, once you divide them into groups, you randomly select from each individual group. Everybody good for a cluster sampling? All right, so let's scroll on down. All right, so let's go into this one. So 1.5, we're gonna get into something called bias in sampling. So when we talk about bias in sampling, it just means that the way we collect it, there's gonna be some natural biasness in that data set. So the first thing is called a sampling bias. So a sampling bias, it goes back to a representative sample. So if you remember, a representative sample means that each individual or each group is equally represented in the sample. So when we talk about sampling bias, one of the bias that we can have is called undercoverage. So undercoverage just means not everybody in the population is getting represented. So here, let me give you an example of that. So can I imagine this is my population? And say we take a sample from that population. All right, so say we have some green, say we have some red. Let's make some blue in there. No, let's not do green. Let's do orange. All right, so let's say that's my population. Whenever you have something that's under coverage, that means that the entire population is not represented. So that means that the entire group are not equally represented. So say if we take a sample, we have my orange and we have red. And that's pretty much it. So does this sample represent what my population look like? Yes, no, no, good. So it doesn't represent what my population look like. And this is what we call undercoverage. So either you want to fix undercoverage, because if anything I get from this sample right here, it's pretty much going to be useless to me because this is not a true representation of the entire population. If I wanted this to be a true representation of the entire population, well, you're going to need more blue than there. You're going to need more green than there. This probably is not going to look the best. But you want something that represents the entire population, because the sample size that we had before, it was only representing the orange and what was it, the red. But if we want something that truly represents everything, like everything should be equally represented. So anytime we talk about undercoverage, it just means a group or multiple group are under coverage or underrepresented in your sample. Everybody good for under coverage? All right, up next we're gonna go into non-response bias. So non-response bias is pretty easy. A non-response bias is just when you set out to go ahead and get a certain sample, but you don't get the entire sample back. So usually that happen when they do, say, phone calls. or they'll send it through the mail, or they might send you an email. So when we talk about non-response is yes, whenever we set out to get a certain sample, but that sample never actually respond to your survey. So kind of think about it, like if you ever gotten like a phone call from somebody saying like, do you want to take a survey? 99% of the time was what the thing that happened most of the cases. Like you hang up on them, or yeah, pretty much you just hang up on them. So that's non-responsive because they wanted you to participate in the survey, but you were not responsive to them. Or they'll send you something to the mail, and what you do, you just throw away that mail, or they'll send you an email and you'll delete that email. And that will be considered non-responsive because pretty much they wanted to get your info, or well, not your info, your opinion, but you never responded back to them. So that's non-responsive. Any question regarding to non-responsive bias? All right. Up next, we're going into something called response bias. So response bias exists when the answer on the survey do not reflect the true feeling of the respondent. So whenever we do a response bias, it's pretty much the way that we formatted the question, or the question itself, it just naturally, people are not going to give us the honest truth about that question. So say if I ask everybody like what your weight is, do you think everybody gonna be 100% honest about how much do they weigh? No. Like people are of course gonna just give me the lower end. Like they're never gonna say I weigh more than this. So they're always gonna give you like the under. So that's not gonna give us a true representation about how much somebody weighs. Or you can ask other questions that naturally you're probably not going to tell them like the truth. Like say if I ask you how tall a person is, like everybody going to say they're taller than what they actually are. So response bias just mean like the way that the question is formatted, it is most likely gonna get like you're gonna get a misrepresentation of the answer. Give me a minute. It stopped sharing, so let me stop share, reshare. And we'll go from there. All right. So what we're gonna do, we're gonna go to part C in type of response bias. So we're gonna go right here to C. So for word used in a survey, it's kind of important like which word they use in a survey because you could kind of mislead somebody to kind of agreeing to something when they actually don't want to agree to that. So like one of the things that you kind of want to do, you want to use neutral words. So you kind of don't want to say good or are you in favor of something or are you against something? Because most of the time they'll just kind of go along with what you're telling them. Because if you're telling them, are you in favor of something? They're most likely going to go like, yes, I am in favor of that. Or if you tell them I'm against something, they're most likely you're going to say they're against something like that. Because if they don't have a strong opinion for either one, they're most likely you will just go based off of the wording of the problem. So for this one, it says, for example, the yes, no question, do you oppose the reduction of estate taxes? Or this one, it says, do you favor or oppose the reduction of estate taxes? So what makes this one good is it gives them both options. So tell them they either favor or oppose. But even a question like this could kind of be misleading because sometimes people will just go based off which word is first. So since they see favor first, they most likely will go with favor. So normally when they're doing a survey, they'll do two type of questions. So one will be worded like this. The other one will be worded like this. And you'll be surprised like how just changing that wording, it will give you a different response. All right, so we're gonna jump into this question right now. So for this one, it says Cold Stone Creamery is considering opening a new store in Alaska. Before opening the store, the company would like to know the percentage of households in Alaska that regularly visit a ice cream shop. The market research obtained a list of households in Alaska and randomly select 150 of them. He mailed a questionnaire to the 150 that asked about ice cream eating habit and flavor preference. Of the 150 questionnaire mail, 4 are returned. So for this one, what could be a bias that they're gonna have here? Cool, perfect. Yeah, that's very cool. Yeah, so for this one, if you look at it, they're gonna have a non-response bias, or they do have a non-response bias, because if you look at it, they sent out 150 questionnaire, but they only got back 4 questionnaire. So it's gonna cause a non-response bias. So how can we actually fix this? Oh yeah. So let me put some people's suggestions. So yeah. So they need to call them back or send them email because they can't really just rely on 4 questionnaire, especially if they wanted to get 150 of that. Like 4, like that's not even a percent of that. So yeah, so they need to call them back or email them or try to find a better way to actually reach out to the 150 household. So they might want to go like door to door. So they could go door to door, but this kind of go back to like how much money you have to spend on it. Because if you actually send out like, depending on how many people you have working for you, if you send out like 20 people to 150 households yet to get these questionnaire, like it's probably gonna outweigh what information they get because the money that they have to spend to get these people to go door to door. So the probably easier route would be to call them back or email them or try to get their attention some other way. All right, let's do the second example. It says a health teacher wishes to research on the weight of college student. She attains a way for all students to her 9 a.m. class by looking at their driver license or state ID. All right. So what type of bias will we get right here? Cool. So yeah, so you're most likely going to get responsive bias because most likely those driver license or state ID, if they were accurate at one time and point, maybe they're not accurate anymore because like and sometimes it's like 10 years later and they still haven't updated their weight. So yeah, so it would definitely be a response bias. So how can we fix this? Like how can we make sure that we get this? Yeah, so perfect. So we weigh the student. Cool. All right, and that's how we could fix that bias that we have. So we could weigh the student, so that way we know exactly how much they weigh, and we're not really worrying about like are they lying to us or anything like that. Yeah, bring a scale. All right, and that's it for that one. Any question for the last prompt? So let's go into the, all right. So we're gonna go into two different type of sampling. So this is type of sampling that you use. So just remember, so far for the sampling we have a simple random sample. We also have a systematic sampling. We have a stratified sampling. And lastly, we have a cluster sampling. So this is additional one. But the difference between these two that we're gonna add on to, these two, pretty much the way that we're sampling, it's gonna have biasness in it. So both of them will be biased. All right, so first we're gonna go over a convenience sample. A convenience sample is, well, let me just read the definition. It's one in which the individual in the sample are easily obtained. Any student that use these type, or sorry, study that use these type of sampling generally have a result that are suspect. Results should be looked upon with extreme skepticism. So a convenience sample is a sample that you obtain very conveniently. So say if I want to find out like the average income for stat students, so say average. So say if I want to figure out the average income for Math 227 student. So what I do, I make Cool. All right, so I want to find the average income for Math 227 students. So what I do, I make my class give me their income for 2019. So how is this a convenient sample? And you remember, you can either shout it out, or if you want, you can just type it in onto the chat board. Whichever one is easier.
Something that's easily obtained.
Yeah. So, but what makes this easily obtained?
From the information off the form that they fill out.
Well, like if you look at this one, am I getting it for all Math 227 students? Or am I just getting this from my class? Well, because if you look at this one, the key thing is that I'm only collecting this information from my class. So if I want to find out the average income for Math 227 student, I have to get it for all of the students who are taking Math 227. I can't just rely on students in my class. So this will make it a convenient sample, because it's very convenient for me to collect this because I'm collecting it from my class. So if I wanted a good sampling, I have to randomly select people from all Math 227 classes, not just students in my class. So what makes this a convenient sample is that I'm only choosing students in my class. I'm not selecting all of the Math 227 students. So that will make that example a convenient sample. Any question in regard to convenient sample? All right. So let's go to a volunteering sample. So a volunteering sample is a data set that you pretty much get because people self-volunteer their answer. So usually a voluntary sample is pretty much the same thing as a convenient sample. Like any type of information that you extract from it is usually not going to be the best information, because pretty much you're going to have some sort of biasness in it. So usually for volunteer sample, it could be like if a talk show host pretty much asks their viewer to respond to a question that they have. Because the thing is, the only people who are actually going to respond to that question are people who are strongly for or who are strongly in favor of that question or strongly against it. But you're really not gonna have people call in and say like, nah, I'm just neutral, because that really wouldn't make any sense. Like, why would you waste your time just to say that you're neutral with that question? So usually you get people who are extremely for or extremely against, but you usually don't get people in the middle because they just wouldn't really care to respond to it. Other way that you could get a volunteer sample is usually when they do online poll. There you go. So anytime you do like an online poll, that usually wouldn't be a good representation. Well, actually, so I'm answering a question. So will Family Feud be an example of a response bias? Well, for Family Feud, would it be an example of a response bias? Because if you kind of look at their question, they always say like we're randomly selecting like 100 male, or we're randomly selecting 100 female, or we're randomly selecting 100 American. So they usually do a good sample, but it could be a response bias based off what are the question that they ask. Because they might ask you like, how honest are you? And naturally, most people are gonna say like, I'm a 9 or a 10 on honesty. So that will be a response bias. But usually for Family Feud, like the way they gather their information, they usually gather the information by randomly selecting like 100 male or 100 female. All right. But that's it for a volunteer sample and a convenience sample. Any question in regard to any of those two? All right, sweet. So let's move on down. All right, so we're gonna go into 1.6. 1.6, we're gonna kind of dive a little bit deeper into a design experiment. So if you remember, experiment is something that we actually give the subject or the individual an actual treatment. So usually we have the explanatory response variable and we have the response variable. So the explanatory is what we give, the pretty much is the treatment. The response variable is how we measure if the treatment is actually working. So say like an easy one would be like a diet pill. So the explanatory variable will be pretty much we're giving them this treatment of a diet pill. The response variable, like if we want to make sure that diet pill work, what can I collect that will tell me that the diet pill is working? Cool, yeah. So you're gonna pretty much collect their weight. So we're gonna see like how much did they weigh before they took the diet pill, and then we're gonna see how much did they weigh after they took the diet pill. Yeah, so we're gonna do before and after. So I'll write that here. So explanatory will be treatment. All right. So anytime we have an experiment, the experiment, you're always gonna have two different type of group. You're gonna have something called a control group, and you're also gonna have a treatment group. So the reason why you usually want a control group and a treatment group is because you kind of want to see if the treatment is working. So you need a baseline. So that's the control group. The control group is my baseline. The baseline would tell me like naturally going back to the weight loss, like how much people could lose if they're just working out by themselves or working out and eating healthy. And then you want the treatment group to see like how much significantly better are they doing compared to the control group. Because say if the control group and the treatment group, both of them lost the same amount of weight, that's kind of telling me that the treatment is not working. Because if control group lost 10 pounds and the treatment group lost 11 pounds, It's pretty much the same. So it's kind of telling me they could have lost all of this weight just by working out and by eating healthy. So that's why you always want a control group. You have to kind of have a baseline of how the treatment should work, and then you see if the treatment is actually working. Any question in regard to control group? All right, so up next we have something called a placebo. So the placebo is what we give the control group. Because the thing is, if we tell the control group there's a control group, they're most likely not going to want to participate anymore because they're not going to want to waste their time getting these treatments, but the treatment is actually just a placebo. So what the placebo actually is, usually is just like a sugar pill, or depending about like what they're trying to prove, say they're trying to see if something can help with cancer. What they do, they usually give them the regular medication or the regular treatment for cancer, and they give the treatment group a different type of treatment to see which treatment actually worked better. A treatment that we are already using or this new treatment that we're trying to see if it works. So for the placebo, they usually give a placebo to a control group. For that way, they can continue participating. And for that way, we could have a baseline. Any question in regard to the placebo? All right. So there's something called a placebo effect. A placebo effect is when people in the control group start actually getting better, but they really shouldn't be getting better. Like the reason they're actually getting better, it kind of like mind over matter. They kind of mentally have convinced themselves they should be getting better because they're actually taking a certain treatment. Because the treatment actually shouldn't help them, but just knowing that they're actually taking a treatment, some of the time will actually make them feel better and will actually help them like cure themselves. But that's what they call the placebo effect. When somebody in the control group actually start feeling better and get better, it's because kind of like they commit themselves that they're taking this pill should be making them better. And that's the placebo effect. Any question in regard to the placebo effect? All right. All right. So in order for us to have the two groups, we should have something called, well, what they call blinding. Blinding is pretty much where either the people taking the medicine or receiving the treatment, they don't know if they're getting the actual treatment or if they're getting the placebo. So there are two different types of blinding. One of them is called a single blind, the other one called a double blind. So what we're gonna go over, we're gonna go over a single blind. All right. So in a single blind, the doctor, they know who's getting the treatment, who's getting the placebo. So in this case, the doctor knows. So they know who's getting it. But what's happening, the patient, they don't know if they're getting the placebo or if they're getting the treatment. So the doctor is assigning this group the placebo, and the doctor is giving this one the treatment. But these patients, they don't know that they're in the placebo group or the control group, and they don't know they're in the treatment group. So that's what the single blind is. So when the doctor, they know who's getting the actual treatment and who's getting the placebo, but the patient don't know they're getting a placebo or if they're getting a treatment. Any question in regard to single blind? All right, so let's go over to double blind. All right, so in a double blind, the double blind is the doctor is blinded, so the doctor doesn't know who's getting what, so they don't know who's getting treatment A or who's getting treatment B. So for this one, we have treatment B and we have treatment A. So we don't know if treatment B is pretty much that's the treatment or if that's a placebo. So the doctor doesn't know which one they're giving to the patient, and the patient also don't know if they're getting the treatment or if they're getting a placebo. So in that case, we have a double blind because the patient don't know if they're getting the treatment or the placebo, but the doctor administering the treatment also don't know if they're getting the placebo or if they're getting an actual treatment. So the reason why you kind of want to do a double blind, because pretty much sometimes like people, if they like say for the doctor, if the doctor know who's getting the treatment, who's getting the placebo, the doctor might be inadvertently more nicer to the people who are getting the treatment because they know since you're taking the treatment, they're more likely to be feeling better. Versus if you're taking the placebo, the doctor might not be as nice as they are to the people taking the treatment because they know this is a placebo. The placebo shouldn't really be helping them. So that's why you kind of want to have a double blinded, yet to kind of avoid any type of biasness. So that's the difference between a single blind where the doctor know, but the patient receiving don't know. But a double blind, the doctor don't know administering it and the patient don't know. Correct. It prevents biasness from the doctor because we don't want there to be any sort of biasness. So yeah, so you kind of want the double blinding. All right, but any question in regard to single blind or double blind? Sweet. All right, so let's move on down. All right, so let's do this question. And I skip explanatory variable, response variable, and confounding variable because we kind of already went over that. So let's do this next problem. It said the English department of a community college is considering adopting an online version of the freshman English course. To compare the new online course to a traditional course, a English department faculty member randomly split a section of her course. Half of the students receive the traditional course and the other half is given an online version. At the end of the semester, both groups will be given a test to determine which performed better. All right, so for this one, first thing what we want to do, we want to say what the experimental unit. So who are the individuals? So in this case, who are the individuals that are participating in the study? Cool. We'll say English students. Yeah, good. English student. So what is the population for which this study applies to? Because who are they doing the study to? Okay, if you kind of look at it, half of the sample get online, the other half get a traditional. But who are they applying that to? Yeah, so freshman English students. Cool. So this one you want to say freshman student or freshman English students. Well, you're more likely want to say freshman English student because we're not doing this for all freshmen. It's only freshman English student. All right, so for part C, what is our treatment? Yeah, good. So we're doing traditional versus online. Yeah. So we're doing a traditional course versus the online course. What is the response variable for this one? Like how do they calculate like which student performed better? Yeah, so we do test at the end. So for this one, why can't this experiment be conducted with blinding? Well, not that we know which student does better, but we know, like, kind of think about what do the student know? Do the student, like, are they gonna be able to see that they're taking a certain course or not taking a certain course? Well, kind of think about it like the reason we can't do a blinding right here because the students are gonna know whether they're in a traditional class or they're in the online course. You can't really hide that from the student. Like they should be able to see, hey, I'm in a traditional class or hey, I'm in an online course. But that's why you can't really do a blinding. So because students. So yeah, so of course students should know that they are taking a traditional course versus a online course and vice versa. All right, and that's it for that one. Any question for that last problem? All right, sweet. All right, so we're all done with chapter one. Hooray. All right, so what I'm gonna do for chapter one, I'm gonna upload chapter one and I'm gonna delete the notes that I inputted for yesterday because pretty much each chapter one note will have all of the notes. So that way you don't have two chapter one notes. You only gotta have one chapter one note, so that way you can know that one have everything. All right. Yeah. All right. Any questions so far for chapter one? Cool. All right. So if you look at chapter one, no math involved, just pure definition. So if I were you, I would be making pretty much like either 5x8 cards or you're doing sheet of paper for each definition. So you do kind of want to go like, okay, some of the definition kind of know like different type of sampling distribution. They'll go over simple random sample, systematic, stuff like that. And you kind of have that like in one sheet of paper for that way you know exactly where to go for that sheet of paper. But just put the definition and just put like example for that definition, especially for like continuous versus discrete, quantitative versus qualitative. You should know how to do those pretty fast. All right. So chapter two is going to be all about drawing. Mhm. Yeah, so pretty much in a single blind, the patient don't know whether they're getting the placebo or they're getting a treatment. And in the double blind, the person administering the treatment, they don't know they're getting the treatment or the placebo, and the person um, or the patient taking the treatment, they don't know they're getting a placebo or the actual treatment. So, yeah. All right. So let's get into 2.1. So in 2.1, we're strictly, you're going to focus on categorical data set. So if you remember categorical data set, your data set that you can put into particular category. So in this section, instead of calling them category, what we're going to do, we're going to call them a class. So say if we're doing gender, if we're doing male, female, pretty much instead of saying gender, we say this is the class. All right, so up next we have class frequency. So class is pretty much just a category. So it will be male or it will be female. frequency, kind of think about it, is frequency. So it's telling you how frequent something happened. So whenever I say class frequency, we're just getting how many times did that category occur. So how many times or how many people fall into that category. So kind of think about it for, if you remember the poll that we did about male versus female, or how many males or how many females do we have? Pretty much the frequency will be how many people chose that they're male and how many people chose that they're female. So that will be considered a class frequency. So class frequency is how many people fall into that particular category. Any question for class frequency? All right, so up next we're going to do class relative frequency. So the keyword here is relative, because relative means relative to how many people participated. So let me give you an example. Say if I tell you last semester I had 4 people who failed the class for Math 227. Did that really help you in deciding on whether you should take me or not? What about if I tell you 4 people out of 4 failed my class? Does that help you pretty much figure out like if you should take my class? Because if you use that 4 people out of 4 failed my class, what percentage is that? Yeah, so 100% failed my class. So it wasn't 100%, so don't worry about it. So that's what class relative frequency is. It doesn't mean giving you the frequency, I'm giving you relative to how many people participate. So in this one, you should be giving a percentage or a decimal value. So class frequency, you give me how many people fall into that class. Class relative frequency, you're essentially doing out of how many people participate, what proportion is in that class. All right. Any question in regard to class relative frequency? All right. And thinking a little bit, we're going to use a calculator. So if you have a calculator out, well, if you have a calculator, take it out for that way you can kind of follow along. All right. So in this section, what we're going to do, we're going to be using a bar graph and a pie chart. So both the bar graph and the pie chart, we use both of these for categorical data set. So we don't use this for numerical data set or quantitative data set. That's going to be 2.2. I'll show you what type of graph you would use for 2.2. But for 2.1, we're either going to be using a bar graph or a pie chart. It really doesn't matter which of the two you use. So what we're going to go ahead and do, we're going to do this problem. And what we're going to do, we're going to do a pie chart, and we're also going to do a bar graph. So let's go ahead and read this question. So it says the night heron and cattle egret are species of birds that feed on aquatic prey in shallow water. These birds wade through shallow water, stalking submerged prey, and they stalk rapidly and downward through the water in an attempt to catch their prey. The article cattle egret are less able to cope with light refraction than any other heron. Gave data on outcome when 240 cattle egret attempted to capture submerged prey. The data are summarized in the following frequency distribution. All right then. Cool. All right, so here are the outcomes. So if you look right here, we have 4 different classes. So we have prey caught on first attempt, prey caught on second attempt, prey caught on third attempt, and prey not caught. All right. So those are our 4 classes. So just gonna make this a little bit easier. I'm gonna say this is A, this is B, this is C, and this is D. So if you look at it, we have for prey caught on first attempt, there's 103 that caught it in the first attempt. Then we have 41 who caught it on the second attempt. We had 3 who caught it on the third attempt. And lastly, we have 94 who caught it, well, didn't catch a prey. So first thing we're going to do, we're going to calculate relative frequency. So remember, relative frequency is relative to however many people participated. So for this one, how many prey participated? Yeah, 240. So right here, we're going to do 103 divided by 240. All right. Any question where I got 103 divided by 240? All right, so I'm gonna switch it over to my calculator. Everybody should be seeing the TI-83, oh sorry, TI-84 plus. So we'll say 103 divided by 240. You got that? Cool. All right. If you're one of those students that have problem converting them to a percentage, the easy way to convert it to a percentage, just multiply by 100. All right. So if you look at that, we get 43%. Let's say 43%. All right. Any question where that 43% come from? All right, so let me move it back to my notes. All right, so the next one we're gonna do 41 or prey caught on second attempt. So say 41 divided by 240. So for this one, I'm gonna do it on my calculator just to make this a little bit easier. So 41 divided by 240. And you roughly get 17%. Right. So then we're gonna do 3 divided by 240. So say 3 divided by 240. And you roughly get 1% for that one. Lastly, we'll do 94 divided by 240. And you roughly get 39%. All right. Any question how I got any of those percentage? Cool. All right. One thing that you should just know, if you add all of these percentages up, it should add up to 1 or 100%. Because the thing is, like, pretty much it's 103 out of 240, 41 out of 240, 3 out of 240, 94 out of 240. If I add up all of those fractions, it should add up to 240 divided by 240, which should give me 1 or 100%, however you want to look at it. So if you do add up those 43 plus the 17 plus the 1 plus the 39, it should add up to 1 or 100%. All right. Any question how we got relative frequency? All right, so I'm gonna test on a quiz. If I ever ask for relative frequency or frequency, it shouldn't be no surprise that this is what I want. Relative frequency should be in percentage. Frequency should be in, well, just a tally mark. So let's go ahead and do a bar graph. All right. So when you're doing a bar graph, the bar graph, you could either do it in percentage or you could do it in frequency. Kind of just depend on you. Like in this case, I'm gonna do it in, what you got? I'm gonna do it in frequency just to kind of make it a little bit easier. Also, like for this one, you kind of want to make some mental judgment because you don't want to go up by 1 because going up by 1 would be crazy. You kind of want to go like, okay, what's the highest frequency that you have? The highest frequency that we have is 103. So you kind of want to go in an increment of a certain value that is going to make it easier to get to 103. So going up by 1, it's probably not going to be the safe bet. What I'm actually going to do, I'm going to go up by 20 just to make it a little bit easier. So we'll say 20, 40, 60, 80, 100, 120. Oh. All right. So if you look at prey caught on first attempt, I said that was A. So I'm going to put A right here. And that's 103. So 103. Cool. All right. So that's 103. Up next we have B, which is 41. Oops, sorry about that. So 41. And we'll put B right there. Lastly, well, not lastly, but prey caught on third attempt, that's C, so that's 3. You should barely be able to see that. And lastly, you have D, which is 39%. So 39% should be slightly below the 43%. Cool. And that's our bar graph. So a bar graph is a nice way to kind of visualize the data set to kind of see what occur most often, what's occur less often. Cool. Actually, D is completely wrong. Because D should be 94. 94 is over here. Yeah, sorry about that. I was looking at the percentage and not the actual frequency. Yeah, it's 94. Cool. So the good thing about the bar graph, it kind of tell you like which one got the highest amount of frequency, which one got the lowest amount of frequency. Because if you look at this one, which are the 2 classes that got the highest amount of frequency? Yeah, so it will be this one, and it will be this one over here. And then if I wanted to know which class got the least amount of frequency, that'll be C. So the frequency table, like, well, sorry, the bar graph, you do kind of want to be able to read the bar graph and you just know, like, how does the bar graph work? Cool. Yeah, for this one, you can also do it by percentage. Like, we'll do it by percentage right now. Because if you look at this one, what's the highest percentage that it goes up to? 43. So we're gonna make it go up to 43. So for this one, I'm just gonna jump by 5. So we'll say 5%, 10%, 15%, 20%, 25%, 30, 35. So we can do it in percentage. So if you look at A was 43%. So we'll say A right here. Yeah. So that's A. So that's 43%. So then we go B. B was 17%. So 17% is somewhere over here. If you look at C, C was 1%. So very small. And lastly, you go with D. D was 39%. And if you look at all 3, well, both of them gave us the same thing. Like you could still see like A and D are the 2 highest. You could still see C the lowest. So it doesn't really matter if you do a relative frequency or if you use frequency. Like the graph should still look the same. Like especially if you're using like any type of software or technology. Like in the software or technology, it should look pretty accurate. All right, but that's your bar graph. Any question in regard to how to construct a bar graph or how to read the bar graph? All right, perfect. So I'm gonna go ahead and minimize this. I could do this. All right, up next we're gonna go ahead and we're gonna do a pie chart. So pie chart, well, should look like a pie. So it should be a circle. So kind of like an easy way to do a pie chart without getting super technical on a pie chart, pretty much just divide the data set. So if I divide it like this, that's 50%. And if I divide it like this, now we divide it into quarters, which is 25%. So you have 25% here, 25% here, 25% here, 25% here. So then you have to just see like, okay, how can I fit all of this into the pie chart? And that's what we're gonna do right now. So if you look at the 4 classes that we have, which class has the highest percentage? Class A, B, C, or D? Good, A. So A is 43%, so that's almost 50%, but not quite 50%. So we're gonna say that's roughly 50%, or 43%. So we're gonna say this is A. And we're gonna color coordinate this. All right, so that's 43%. Up next, we're gonna go ahead and we're gonna do 17%. Because if you look at 43% plus 17%, that should give you 60%. So that should give me a little bit more than 50%. So we're gonna say somewhere from here to here, that's roughly 60%. So let's take this one. Let's change the color. We'll change it to blue. In case you're wondering, that's A, that's B. All right, so we're not gonna do C right now because C is 1%. That's not gonna take up that much. We're gonna do D. So if you look at D, it's 39%. So pretty much it should take up everything. So we'll take this on. So we'll say there we go, D. And we'll change it to yellow. Good. All right, and that's our D. And lastly, we're gonna do C. We'll see. There's that little piece right here. So just by looking at the pie chart, they'll give you the same amount of information as a bar graph. Because just by looking at the pie chart, which of the 2 classes are the majority? Well, it should be D and it should be A. You can also look at which one is pretty much doesn't take up a lot. Oops, sorry about that. It should be C. So using a pie chart, using a bar graph, both of them are pretty much the same thing. There's no real con or pros against each other. They're both gonna give you the same amount of information. They're gonna tell you like which one occurred most often, which one occurred the least often, but there's no real pro or con for either one of them. All right. Any question in regard to a pie chart versus a bar graph? All right, so that should be it for bar graph versus pie chart. All right, up next we're getting to 2.2. So in 2.2, we're gonna be focusing on quantitative data set. So for quantitative data set, what we are going to focus a little bit on, we're going to focus on the distribution. So when we talk about distribution, we're talking about like where is most of the data set is located at, because that's what distribution is saying. It is saying how to distribute it. It's distributed where you have most of the data set to the left, most of the data set to the right, or most of the data set to the middle. So depending on where most of the data set is located at, we're going to use a special type of word to kind of say that. So let's focus on this one. And in case you can't see, on the very bottom it says skew left. So this is the skew to the left distribution. So look at this distribution. Where do you have where the least amount of the data set is at? Is it in the left side? Is it in the middle? Or is it in the right side? Yeah, so if you look at it, it's the left. So that's why they call it skew left, because the left side has the least amount of data set. So if the left side of the distribution is has the least amount of distribution or the least amount of data set, you call it skew to the left. Let's go on to this next one. So here goes the left side, here goes the right side, and here goes the middle. In this case, where do we see most of the data set at? The left side, the middle, or the right side? Cool. The middle. So when your data set is mostly in the middle, you call that symmetric. Lastly, we have this. Left, middle, right. So for this final one, where do you have the least amount of the data set? The left side, the middle, or the right side? Yeah, good. So the right. So that way you call it skew to the right. So you do kind of want to know these words because these are words that we're going to be using out throughout the semester. So if you hear me saying skew to the left, symmetric, or skew to the right, these are words that you should kind of know what are they talking about. So it's telling me the distribution of the data set. So if most of the data set is on the right hand side, we call it skew to the left. If we have most of the data set in the middle, it's symmetric. If most of the data set is on the left hand side, we call it skew to the right. All right, any question in regard to the distribution? Wait. All right, so in this section, we're gonna be going over a dot plot, stem and leaf display, and a histogram. So these are the three graphical methods that we're gonna learn for this section. All right. So the one we're going to start off with, we're going to start off with the dot plot. The dot plot probably the most easiest one. Well, hopefully the most easiest one. All right. So if you look at this question, it says a survey asking how many siblings do you have these results. So right here, it's telling me the siblings. Right here, it's telling me the frequency. So if I look at this one over here, so if I'm looking at this one over here, for this one, how many people have 0 siblings? Good, 3. So since we have 3 people who have 0 siblings, that means we're gonna have 1, 2, 3. So you have 3 dots on 0. And for this one, you stack them on top of each other. That's how I know that you have 3 people. Well, we have 3 people who have 0 siblings. Right. Any question for that first dot plot? All right, how many people do we have that have 1 sibling? Good, so we have 1, 2, 3. How many people do we have that have 2 siblings? Yeah, 1, 2, 3. How many people do we have that have 4 siblings? Or sorry, 3 siblings? Yeah, 6. There we go. 1, 2, 3, 4, 5, 6. How many people do we have that have 4 siblings? No, forgot to. How many people do we have that have 5 siblings? 0, so just leave it blank. Lastly, we have 1 person who has 6 siblings. Cool. All right, and that's your dot plot. So we'll put it right here. Any question on how I constructed that dot plot? All right. If I were to ask you, is this a discrete or continuous data set? What type of data set would it be? So here, let's do this. Don't put anything on the chat room right now. We'll say A is discrete. We'll say B is continuous. So let's do a poll. All right, so if you think it's discrete, you put A. If you think it's continuous, press B. How did we get D? D doesn't stand for discrete. All right, cool. So let me end the poll. Let's share the result. All right, so if you look at that, 88% of you said A, which is discrete. 8% of you said B, which is continuous. 4% of you say D, which was nothing. So for this one, the answer should be A, discrete. Because you kind of remember for this one, you either have a sibling or you don't have a sibling. Like you can't have half of a sibling, a quarter of a sibling. You either have a sibling or you don't have a sibling. All right. Any question in regard to this last problem? Right. So let's see if you can answer this question. How right. How many people have less than 3 siblings? And the question about labeling, no, you don't have to label it. All you have to do in the bottom, you put 0, 1, whatever the discrete numbers are. Cool, yeah. So for this one, yeah, the answer should be 3. Oh, sorry, should be 9. Actually, that doesn't really work out well. Cool. Yeah, because remember, less than 3 mean you don't include the 3, so you only want to include 0, 1, and 2. Good job. So it should be 9. All right, so let's move on from a dot plot. All right, so let's construct this one. So this one, we're also going to do a dot plot. So for this one, we have Ben and Jerry. So we have 36 different flavor for Ben and Jerry. And we want to create a dot plot for this. So we have the calorie for each different color. Well, not color, each different, what you call it, flavor. So we have one flavor is 210 calorie. We have one flavor is 220 calorie, so on and so forth. So what we're going to do a dot plot for it. So how many flavors do we have that have 210 calorie? We have 1, 2, 3, how many? Yeah, so you only have 1. So we'll put 1 right here. How many flavor do we have? That's 220. Yeah, so you have one. Perfect. All right. How many do we have for 230? Two. And the last one, how many do we have for 240? Yeah, 240 is one. All right, so what I'm gonna go ahead and do, I'm gonna go ahead and finish out this problem. So that way we could kind of get into it. So 250 is 1, 2, 3, 4. $260 is 4 again. So 1, 2, 3, 4. All right, so that's how your histogram should look. Well, sorry, not histogram, dot plot. Everybody good with this dot plot? All right, quick question. Let's do a poll again. So same question. Just tell me if calorie is a discrete or if calorie is continuous. So if you say discrete, press A. If it's continuous, press B. So, all right, go for it. All right, so let's end this polling. We gotta go. Let's share the result. All right, cool. So if you look at it, 29% or 8 of you chose A, which is discrete, and then you have 71% of you, which is 20 of you, chose B. So for this one, the correct answer, it should be B, continuous. Because the thing is, it's not always going to be exactly countable, because you could get like 210.5 calories. There's not always going to be a discrete value or countable number. So that's why it should be considered continuous. Because depending on like how exact you want to be with how much calorie is in your ice cream, you could take it get a more exact answer. All right. Any question on how I created this dot plot? All right, so let's answer these questions. So it says, how many Ben & Jerry flavor ice cream have 300 or more calories? So how many Ben & Jerry flavor do we have that have 300 or more calories? Oh, 10. Perfect. So we'll say 10. For the 10, would the 10 be considered a frequency or relative frequency? Free. Cool, yeah. That's a frequency, yeah. Perfect. So for this one said, what percent of Ben & Jerry flavor ice cream had 300 or more calorie? So for part B, what do I have to do with pretty much what with the 10? What should I do with 10 if I want to find the percent? Yeah, so you divide it by 36. If you do 10 divided by 36, all right, so you can either put 0.27 with a bar on top of it, or you can put 27.7%. All right, but that's it for B. Any question for B? All right, so let's do C. So for C, you said, are there any Ben & Jerry flavor ice cream that are unusually low or high in calorie? So let's go back to this. Anything kind of like pop out at you? And if it is popping out at you, like what? Good. So this should definitely be popping out of you. Like the reason why it should pop out of you, because you have to look at the distance that's kind of going from that high number and the next highest number. Because that high number is 490, but if you look at the next highest one, it's 360. So that way you should kind of be saying the 490 calorie. Like that one should be kind of jumping out at you because there's such a big difference between that value and the next highest value. All right, but that's it for that one. Any question for that last one? Cool. Yeah, so technically there's actually a formula to check to see if something is an outlier. So right now we wouldn't say the outlier because we still haven't done the process of determining if it's an outlier. But yeah, like if something is abnormally large or abnormally low, we usually call that an outlier. Good. All right, so all right, up next we're gonna go ahead and we're gonna do the stem and leaf plot, and I think that should be it for today. So a stem and leaf plot is just another way to visualize data set if we have numerical data set or quantitative data set. So for this one, we're just gonna jump right into the problem. All right, so here's the data set. So I went to the 2019 season for the NFL, and I wanted to see how many touchdown passes each team threw. So here's the data set from highest all the way to lowest. So the lowest amount of touchdown passes a team threw was 16. The highest amount of touchdown passes a team threw was 37. Cool. Everybody kind of go with that? Sweet. All right. So when we're doing a stem and leaf plot, always find the minimum and find the max. So for this one, I already kind of told you the minimum. The minimum was 16. And the highest number was 37. All right. Everybody good? How I got min or the minimum is 16 and the max is 37. All right. So when we're trying to find the stem and the leaf, you're going to put your one digit. So you're going to put the numbers that are in the one place. The stem, you're going to put whatever's left over. So what you're going to do right now with the min and the max, we're going to just erase the one digit or the number in the one place. So for the minimum, what's the number in the one place? Hopefully you still remember the one place. Cool, 6. So erase 6. What's the number in the one place for the max? Perfect. So what are the two numbers remaining? Well, technically 1 and 3. So you start off at 1 and you keep on going until you get to 3. So you use stem is 1, 2, and 3. So that's how you figure out the stem portion. Any question on how I figure out the stem portion? All right. up next, we're gonna go ahead and we're gonna do the leaf. So for the leaf, you wanna find all of the numbers that start off with that stem portion. So if you look at the stem, so right now we're gonna do this stem right here. So we want to look for all of the number that have a 1 in the 10 place. So all of the number that have a 1 in the 10 place are these. Any question why I selected those 6 numbers? All right. So let's look at 16. So the 1 already go in the stem. So the 6, you put in the leaf. So right here you put 6. And that's how we represent 16. Because if you get the 1 from the stem plus the 6 in the leaf, it makes 16. So let's do the next number, 17. So sorry about that. So if you look at 17, the 1 go to the stem, the 7 goes here. So, all right. So you're almost right in the chat. You forgot about something. So if you look at 18, is there only one 18 or how many 18 do we have? You have 3 18. So since you have 3 18, that means you have to put 8 3 times. So close. And then you finish it off by putting 9. And that's it for the 1. Any question in regard to stem of 1? All right, so now we're gonna get all of the numbers that have a 2 in the 10 place. So pretty much your 20s. So let's do this. Yeah, if you have repeated number, you want to include that because if you don't include that, you're misrepresenting the data set. You don't have to put a comma because the thing about the leaf should always be a 1-digit number. So you don't need to put a comma because it's already naturally assumed that one number in the leaf corresponds to the one number in the stem. You don't have to put them in order, but it's usually kind of nice if you have them in order, especially if you want to figure out like, say like later on we're gonna do median. If you want to do the median, you kind of want to have them in order. All right, so let's go ahead and do the 20. So if you look at it, you have 220, so that's 2 zeros. If you look at it, you have 21, which is just 1, so you put 121. If you look at 22, 22 actually repeat 5 times. So we put 1, 2, 3, 4, 5. If you look at 24, 24 occurred 2 times, so you go 4, 4. 25 is 5. 26, 2 times. 27 is 7, 7. 28, 2 times. Lastly, 29 and 29. Cool. So that's your stem for 2. Any question? We got the stem for 2. All right, lastly, we're gonna do the 30. So if you look at 30, you have 3 30s. So you go 1, 2, 3. If you look at 31, you put a 1 right there. If you look at 33, you put a 3. 36, you put a 6. And lastly, you have 37, which you put a 7. All right, and that's your stem and leaf plot. So the stem and leaf plot, if you kind of look at the dot plot shows more detail because you're putting a dot for each individual value. Versus in this one, you kind of have a range because you're putting all of the numbers that are in the 20s, all of the numbers that are in the 10s, all of the numbers that are in the 30s. So you have a range versus in the dot plot, it is how many times did that individual number repeat. So the good thing about doing a stem and leaf plot, you can actually be able to see the distribution. So kind of imagine if you get this, copy this, we'll put it right here and Really work better. All right, so let's do something different. Kind of think about if you flip it over, you should be able to see what type of distribution does that have. So if you look at this one, what type of distribution would you say it has? Would it be skewed to the left, skewed to the right, or would it be symmetric? Yeah, unfortunately, middle wouldn't be the correct word you want to use. But yeah, you want to say symmetric. Cool. So we'll say symmetric and that's it. So the stem and leaf plot, you could actually use the stem and leaf plot to see the distribution of your data set. All right, but any question in regard to how we did that stem and leaf plot? All right, so we're gonna go ahead and we're gonna go ahead and stop here. All right, so we're gonna stop here. So what I'm gonna do, I'm gonna upload all of chapter 1 notes. I'm gonna take away the chapter 1 notes that only have what I did yesterday and replace it with the notes that I have today, which should be the completed version. I'll also upload chapter 2 in case you arrive late or left early, for that way you can kind of go ahead and fill it out and stuff like that. But any question in regard to anything? And just remember also tomorrow there is no quiz. The next quiz will be on Thursday. And that will be technically the first real quiz that you have. Any questions? All right, sweet. If there's no further questions, that's pretty much it for today's class. So let me stop the recording.